In this episode of Tencent Cloud Enterprise Unboxing Time, we will walk you through business release and migration, covering 5 key parts. First part, workload migration from VMware to TCE. After resource creation, you can proceed with workload deployment. If you are using VMware, you can leverage the Tencent Cloud Enterprise's stable and reliable migration tool, Go to Cloud, to seamlessly migrate VMS from VMware to Tencent Cloud Enterprise. Now, let's demonstrate this by migrating an Nginx server from VMware to Tencent Cloud Enterprise CVM. Log in to the source VMware VM and run the migration tool. You'll see that the Go to Cloud process is running and the migration script is ready for execution. Switch to the Tencent Cloud Enterprise tenant console and choose Instances. We have prepared 3 target machines here. Log in to one instance and verify that no Nginx service is running yet. Go back to the source server and execute the migration script. Go to the CVM console. Verify that 3 source hosts have been imported. Click the Migration Task tab, and you'll see 3 tasks in the migrating status. In the CVM instance list, you can see that these target hosts are in the online service migrating status. Refresh the task list to check the real-time migration progress. After all migration tasks are complete, you will see 3 running instances displayed in the CVM list. Log in to a target instance and check whether the Nginx service is running. If not, start it. The whole migration process is complete. Second part, batch ops for VMIs. Through Application Operations Platform, Tencent Cloud Enterprise delivers business application-oriented ops capabilities. It allows you to query tenant cloud product resources from CMDB. It can also allow you to rapidly execute scripts in batches and upload files on the UI. This product significantly improves ops efficiency. After logging into the Tencent Cloud Enterprise tenant console, choose Application Operations Platform, locate CMDB, and click Resource Directory. Here, you can see an overview of cloud resources synchronized from cloud products, currently covering core services such as Cloud Virtual Machine, Cloud Block Storage, Virtual Private Cloud, and Cloud Load Balancer. Click Host. All VMs and their details under the current tenant are displayed. The details include IP addresses, operating systems, and other key information. On the Application Operations Platform page, locate Host Operations. Click Script Management and Custom Script. The platform offers in-browser script editing and upload functionality, enabling UI-based script management. On the Application Operations Platform page, locate Host Operations and click Quick Execution. Then you can rapidly initiate a task. For example, you can execute scripts, distribute files, and run Ansible playbooks. Here, select the script type and a pre-configured custom script. Check the code content. Configure the execution account, select target hosts, and click Execute. On the Execution Details page, check the whole execution status, the execution status per host, execution time period, and script output. In this example, the script runs successfully and returns the expected strings. Third part, deployment of containerized applications. With the widespread adoption of cloud-native technologies, container-based deployments are increasingly prevalent. Tencent Cloud has launched the Tencent Kubernetes Engine product. TKE is a container-centric, highly scalable, high-performance container management service designed based on native Kubernetes. TKE is fully compatible with native Kubernetes APIs, offering a series of capabilities such as efficient deployment, resource scheduling, and dynamic scaling for containerized applications. It addresses environment consistency issues during development, testing, and operations, enhances the ease of managing large-scale container clusters, and helps users reduce costs while improving efficiency. To deploy a containerized application, first, create a cluster. Then upload the container images required for the application deployment. Tencent Kubernetes Engine provides the necessary product capabilities for configuration. For demonstration simplicity, we will use pre-existing clusters and images. Now, let's use stateful set as an example. To demonstrate how to create an application workload, go to the cluster page and click the newly created cluster. On the cluster details page, choose workload and stateful set and click create. Specify a workload name. Select the namespace and type and configure specific settings. For the containers in the pod, such as the container name, image, selecting the image uploaded in previous steps, CPU limits, and memory limits. Once configured, click Create Workload. After submission, you will be redirected to the Event tab of the workload. Shortly after, an event indicating the successful creation of the stateful set will be displayed. Click the Pod Management tab for the workload to view the list and details of pod, including instance name, status, node IP of pod, and container information within the pods. For example, you can check the container name, container ID, image tag, and status. Go to the cluster details page. Click Service and Service. Click Create. Specify a service name. Select values for namespace, service access, and port mapping. Then, bind the previously created stateful set. After configuration, click Create Service. Shortly after, the service will be successfully created. You can check its type and IP address on the service page. Then, click Ingress. Let's create an ingress for the application and bind its forwarding rules to the service previously created. Click Create. Specify the ingress name. Select the ingress type, network type, and namespace. Set parameters in the forwarding configuration area and click Create Ingress. After creation, copy the backend service address of the ingress. Run the wet command on a network-accessible VM to verify service connectivity. The response indicates successful application deployment. At this point, the entire application deployment process is complete and the application is ready for external access. Fourth part, deployment of microservice applications. Service Framework provides enterprises with one-stop full lifecycle microservice management capabilities, covering core functions such as application deployment, service registration and discovery, configuration management, traffic control, and monitoring and operations. It helps enterprises simplify the process of building microservice architectures and improve system stability and operations efficiency. We will now introduce the microservice workload deployment capability. First, navigate to the Microservice Framework page and choose Cluster. Create a container cluster named Cluster 1. For demonstration, we have already created it. Application Management is one of TSF's core features. Choose Application Management and create an application. In the displayed dialog box, specify the application name. Select the container deployment mode. Select Java for programming language. And select Spring Cloud for development framework. After the application is created, the Image tab is displayed. Click Upload Package, Image. Select Jar Package Deployment. Select the JDK version and upload an application package. Click Upload Package and create image. The progress for uploading one provider jar package is displayed here. Then, upload one consumer jar package in the same way. After two packages are uploaded, click the Deployment Group tab. Click Create Deployment Group. Specify the group name. Select the pre-created cluster. Select the namespace and the Kubernetes namespace. Click Save and Next. Ensure that the group name is unique. Next, select the previously uploaded image and configure the resources. Click Expand Container Advanced Settings to set Keep Alive check and Readiness check. Configure other parameters. After configuration, click Submit. You can check the deployment progress on this page. When Succeeded is displayed, the deployment is complete. On this page, you can also check relevant logs and events, which facilitates further troubleshooting during the deployment. Go back to the Application Management page. Click the target application to go to the Application Details page. On the Deployment Group tab, the newly created deployment group is displayed. On this page, you can perform a variety of operations on the application, such as editing YAML, viewing logs and events, restarting the application, and stopping the application. When the application is running, you can go to the details page at any time to check the deployment group's Kubernetes events, basic information, logs, and instance statuses. That's all for the deployment process of a TSF application. Final part: data backup. Tencent Cloud Enterprise offers the Backup Recovery Center product designed for backing up and recovering tenant resource data. We will demonstrate its data backup capability using Cloud Object Storage. Log in to the Tencent Cloud Enterprise Tenant Console. Go to the Cloud Object Storage page. Click Bucket List. Locate a bucket and view its details. On the File List page, there is a file named test.txt. Then, go to the Backup Recovery Center page. All cloud products that support backup are displayed here. Click COS Backup and Protected Instance List to check the list of instances that are already protected. Click Create Backup. Add the storage bucket you want to back up. Set the backup policy to Execute Now or Periodic Backup. Set the backup name. On the Protected Instance List page, the newly added bucket is displayed. Locate COS Backup and click Backup List. You can see the created backup task and the backup progress. Refresh the page. Once the backup status changes to All Successful, we will simulate a data loss scenario to demonstrate the recovery capability. Go back to the Details page of the target bucket under the Cloud Object Storage page. Locate the test.txt file and delete it. The bucket will now be empty. Return to the Bucket List page and create a bucket for recovery. Go back to Backup Recovery Center. Click COS Backup and Backup List. Select the most recent backup task and click Restore. Select the target COS bucket and click OK. You can now see the recovery progress. After the recovery is complete, go back to the Details page of the target bucket under the Cloud Object Storage page. Refresh the page. On the File List page, the deleted test.txt file has been successfully restored, proving the backup and recovery function is effective.